and welcome back to Sec 110. Mr. Arnke back with you today on Chapter 5, Networking and Server Attacks. So let's get started. We're going to talk about how different types of networking-based attacks are carried out and how servers are attacked. Now, first things first, let's talk about networking-based attacks. Now, this is where we have several attacks that we can group in that will involve either targeting a network directly or processes that rely on that network. Now, these attacks can be grouped into two primary categories, interception and poisoning. Interception is designed to, as the name implies, intercept network communications. It's not trying to stop it, it's just trying to capture it midstream. The most common ones we deal with are man in the middle, man in the browser, and replay. These are going to essentially capture the information that's coming through, store it in some way, and then pass it forward. Then we have one that's kind of similar to that in that it's intercepting traffic, but it's usually intercepting it to be able to add extra information, poisonous data that can contaminate normal network traffic. So things like ARP poisoning, DNS poisoning, or privilege escalation. Now let's talk about interception attacks first. As I said, man in the middle, man in the browser, and replay. Man in the middle, commonly abbreviated as MITM, is the interception of legitimate communication and forging a fictitious response to a sender. The two computers are sending and receiving to one another, so we are able to facilitate normal conversation, but in this case, the data that's being trafficked can be stopped by a third party or possibly more and be able to be manipulated in that way. Now, an MITM could occur between just two users sending and receiving. The majority of the time, however, most MITM attackers are not quite so provincial. They try and go after something that's going to provide a large number of avenues of attack, or what we would call a large attack surface, such as a server. A server is going to handle connections that could number in the tens, hundreds, or even thousands. We can see here a conceptual attack on the upper right. You can see that instead of the direct route between sender and receiver, we see that crossed out, we instead have this intermediary third party. Now, in the case of an MITM attack actually being executed, we can see here Bob and Alice, which are our usual send and receiver, are sending one another public key information as well as account number information. So we can see that encryption is being broken because it's being intercepted. Now, man in the browser attacks intercept communication between parties to steal or manipulate, traditionally using a browser and the underlying computer. Man in the browser attacks usually start off with a Trojan that's infecting the computer and installing some kind of plugin or extension into the browser's configuration. When the browser is launched, the extension is activated, running the malicious code. In certain cases, a specific web page will be activated, looking for usernames, passwords, account numbers, things like that. When the users click submit, at that point, the browser is then able to essentially be manipulated into allowing the extension to keep all the data from the fields and even may modify some of it. So in certain cases, people can actually phish for passwords by having somebody retype a password and sending that through and saying that there was an error. So trying to make sure that people type the password correctly that they're trying to send in. The advantages of this kind of attack: most MITBs are distributed through Trojan browser extensions, making it very difficult to see that malicious code is present on the system. An infected browser could remain dormant for months. An MITB software is exclusively within the web browser, so that means that it's difficult for standard anti-malware software to detect it. So if we reach back a little bit and we think about what malware is, it is without the user's or owner's knowledge or consent. So if they download something and they think that it's something potentially helpful rather than something potentially malicious, that is a knowledge thing, not a consent thing. Replay attacks are a little bit different. An attacker is going to make a copy of a transmission before sending it to the original recipient, and is going to use that copy later. So I talked about this. The interception of the data can lead to capturing credentials or capturing some kind of information that can be used for personal gain later on. Now, how do we prevent replay? How do we prevent any kind of man-in-the-middle or interception-based intrusions? Well, both sides can negotiate and create a random key that is valid for a limited period or a specific process. If you deal with wireless technology, you often hear the term TKIP, Temporal Key Integrity Protocol. That renegotiates its key every 10,000 transactions. So again, all it's trying to do is prevent an outside user from trying to gain enough information about the initialization vectors and transition information about the packets to be able to duplicate or brute force through them. Now, we can also make sure that timestamps in the messages are present, and that any message that falls outside of a normal parameter of time is automatically rejected. This would allow basically to prevent what would be considered normal latency from being disguised into a potential attack. Now let's take a look at poisoning, ARP, DNS, and privilege escalation. ARP, or Address Resolution Protocol, is where we're able to fill out the difference between a MAC address, which is the local identifier we tend to use, and then IPs for a default gateway, public interface. So if the IP address for a device is known but the MAC is not, then the computer is going to send an ARP packet to figure this out. All computers that hear the ARP reply will cache the data. So this allows a spreading effect to contain network information much more consistently, so that everything is updated whenever the ping goes out. MAC addresses are kept in a cache that is used for future reference. It'll be usually 5 to 10, maybe even 15 minutes that it's kept in duration. Now, ARP poisoning relies on MAC spoofing, which is imitating the computer by using the hardware address. Instead of having the real hardware address, which would be the traditional MAC address identified by the NIC, there can be another one that's inserted by means of a virtual NIC or just by editing the packet on transition. So once the MAC has been executed and the spoof is on in terms of the ARP poisoning, we've got a couple of different things that can go on with the MAC. Data theft can happen because the attacker will now be receiving data that was intended for that MAC. Prevention of internet access can essentially block the internet gateway by providing an invalid MAC. Man-in-the-middle attack can be done by spoofing the MAC, and then denial of service attacks can also be done, making sure that, similar to the internet access one, we can have traffic destined for the target to fail. So that's the same attack from both directions. So if we have a substitution of the MAC for the network gateway, that's a prevention of outbound traffic. Denial of service is a prevention of inbound traffic. DNS poisoning is basically corrupting the domain name system that we use to resolve an IP address to a domain name, or FQDN. So if we go to google.com, that is a fully qualified domain name. It has the World Wide Web handler, www, Google, which is the name, and then .com, which is the TLD, or top-level domain that we deal with. The IP address that is the actual universal resource locator that we should use if we're trying to be more specific is 74.125.47.99. Now this is just one of many. They have several what are called bastion hosts that receive information and pass them into internal servers. So don't go bookmarking that one just yet. But the idea is human beings remember semantics much better. If we have some meaning attached to something, we're able to figure out the information. So like wku.edu, 3 random letters, 2 consonants and a vowel. What does that mean? Well, if we know it's a .edu site, that means it's a school. If we see a C at the end, it probably means college. If we see a U at the end, it probably means university. So if this person knows Western Kentucky University is WKU, wku.edu makes sense. The school that I work for, cfcc.edu, is Cape Fear Community College. So if you know Cape Fear Community College, and then you can look up CFCC, you can find the website pretty easily. Now, there are 2 locations for DNS poisoning to occur: the local host table or an external DNS server. One is obviously much more devastating than the other because it affects several more hosts. Let's look at the graphic for figure 5.4 in the bottom right here. We have an attacker computer, which basically says, what is the address of evil.net? Very creative. The valid DNS server will say, please send the IP address of evil.net here, and then we have the DNS server on the other side. Here are all the evil addresses. Good, better, and best.net. Now, attack step 4, the good user or the uncompromised user is going to say, what is the address of good.net? Well, because the DNS server is posing as a zone transfer server or as a higher level domain server, what we would call a primary DNS server, it can then feed false information into the secondary DNS server or local DNS server that the good user is trying to get. So what would have been a perfectly normal DNS request to find good.net is now receiving the information for evil.net instead. So there's a substitution that gets set. Privilege escalation. This is one that gets used frighteningly often. Access rights are privileges to access hardware and software resources granted to users. So traditionally, when we talk about permissions and things like that, especially for network resources, we often talk about rights and permissions. Rights are specific abilities that allow you to perform tasks on a system. Permissions are what allow you to make certain changes, such as reading, writing, deleting, modifying, executing. Privilege escalation is taking advantage of a software vulnerability to gain access to resources that a user would normally be restricted from gaining access to. There are two types of escalation that we traditionally see. When a lower privilege user accesses functions restricted to a higher privilege user, we call this vertical privilege escalation. If we have a user with restricted privilege that accesses different restricted functions of a similar user, this is called horizontal privilege escalation. So if, John Smith tries to get into Jane Doe's email functions or things like that, those are considered to be horizontal because in this example, they're both at the same level of hierarchy in their particular organization. If somebody were to take, if John Smith, again, being a naughty boy, we're trying to get into Elizabeth Doe's information, no relation, and that is John's supervisor, then that would be called vertical privilege escalation. So if you're going from a point of ground level or relative ground level and going up, trying to gain function, that's vertical. If you're trying to just gain access to somebody else who's at the same level of hierarchy, that's horizontal. Server attacks. Boy, oh boy, do we have several of those. We've got 6 primaries here: denial of service, web server, hijacking, overflow, advertising, and browser vulnerability. Server attacks are where a compromised server provides threat actors with privileged contents or provide an opening for attacking devices that access that server. There is a type of attack called pivoting that we do to where we gain access to something under normal circumstances, and then we use that access to gain access to something else, so a network that may be attached to. So here in the example, they say a device that accesses the server. If we were to compromise a DNS server, as we showed in the graphic a little bit ago, we could provide false information that could redirect information and allow us to have privileged access to someone else's computer. Then we could gain access to things that they had access to, and so on and so forth. A lot of hackers will hide behind multiple proxies by hacking into other people's computers and using them as a kind of shield. Denial of service attacks. Most commonly we deal with DDoS, which is distributed denial of service, where we have hundreds or thousands of devices flooding a server with requests, overwhelming it and preventing it from responding to legitimate requests. You can also have what's called a Smurf attack. This is where an attacker will broadcast a network request to all computers on the network, but changes the address from which the request came. So IP spoofing, we talked about MAC spoofing a little bit ago. You can do the same thing with an IP address. It's much, much easier. What essentially this does is the victim's computer, whoever's IP is being spoofed, is going to essentially have a broadcast flood that's going to hit it because it acts as though it's asking for a response from all of the computers that received the network request. So then that computer becomes overwhelmed, is again unable to respond to normal requests. There is a measure of bandwidth that is able to be processed. DNS amplification can be done through denial of service as well. This is where you redirect valid responses to somebody. So this is going to use publicly accessible and open DNS servers to flood a system with DNS response traffic. SYN flood, synchronization flood, is going to take advantage of the procedures used to initiate a TCP/IP session. So if we look at the graphic here on the right, we see a SYN flood attack being held. The attacker's computer is going to send SYN segments in the IP packets with modified source addresses. So the server is now going to see that it's waiting for replies from computers that do not exist. So the SYN flood is basically going to say, there's a ton of synchronization information that's being sent through. I'm trying to send the SYN-ACK back. These computers don't exist, so it's going to hang because it's not going to get the timeout quite as quickly as it should. So anything with a SYN flood is going to either block up the server or block up a computer by manipulating the necessary handshake, the 3-way handshake we're used to, for TCP/IP processes to go about normally. Web server attacks, we can see here kind of the distributed web server application infrastructure. This is a really nefarious type of attack these days, excuse me, because everybody relies on the web to be able to access, you know, the broad spectrum applications that we need to exchange things like e-commerce or banking, or you know, sites like Wikipedia that allow us to access a lot of information, especially information that's up to the minute on certain sources. Zero-day attacks are an attack that exploits a previously unknown vulnerability, meaning that it's been 0 days since the producer or custodian of the application has been able to prepare for or defend against the attack. Traditional network security devices can block traditional attacks, as one would assume, but web traffic attacks can be a little bit different because HTTP traffic has to flow pretty freely in order to run normally. So if we start truncating the ability of HTTP traffic to flow, we're going to start cutting off legitimate traffic. We have what's called a type 1 error, and that goes very poorly for us, so we don't want to do that. So instead, we leave ourselves vulnerable and instead have to alter our ability to protect our attack surface. Now, there are several different types of web application attacks that target user input, very common thing, and they tend to be grouped into two categories: cross-site attacks and injection attacks. In a cross-site scripting attack, or XSS, the threat actor is going to take advantage of a web application that accepts user input without validating it before passing it back. So in certain cases, you're going to have a form that accepts something and then sends back some kind of response, but it may not necessarily validate what that input is, which means that commands that the server could then interpret as administrative commands could then cause potential problems. So you could have, tables that get corrupted, or databases that have, primary keys exposed, or passwords, things like that. So when we have a victim visiting an injected website, malicious instructions cause some kind of alteration to the output. Some XSS attacks are designed to steal information, and they're retained by the browser when visiting specific sites. Other ones will just try and corrupt or prevent information from correctly processing. XSS attacks requires a website that meets two criteria. It accepts user input without validating and uses input in some kind of response. So in this case, we see here in the graphic, the Contoso bookmark page has a name field, a description field, and a bookmark field. And it allows you to store a local bookmark to be able to find information quickly. In this particular case, in the bottom section, we see here, thank you, Abby, for your submissions. That means that this particular page takes the name field and uses that to send a custom reply upon confirmation. So this means that we have input and output that is passing back and forth. That kind of cross-site scripting, that kind of attack, rather, cross-site scripting is very, very common on these sites. XSRF, or cross-site request forgery. This is where we have a user's web browser settings manipulated to impersonate somebody. So here we have a cross-site forgery. The attacker forges a fund transfer request from Bank A, embeds it into an email hyperlink, and sends it to the victim who's logged into Bank A's website. They unknowingly click on the hyperlink using, clickjacking or something similar, and the request is sent to Bank A with the verified credentials. So at this point, there's an automated request that's being processed to transfer money or some kind of valuable material. Could be information, could even be information, where the server receives the request, quote unquote request, and then validates it and sends it on to the attacker. Now, how might we combat this? Well, of course, multi-factor authentication, making sure that data inputs are sanitized, that sort of thing. If a user is currently authenticated on a site and tricked onto loading another page, the inheritance principles that we already know exist for files and for directories are going to be in the browser as well, allowing the attacker to perform functions as if they were the victim in terms of their identity and privileges. Injection attacks. Again, we see an input form, right? This is going to introduce a new input in order to exploit a vulnerability. So we see here in the bottom right, this is where SQL injections are occurring, structured query language. This is a very common attack to try and manipulate database servers. So databases, of course, are just rows and columns like you would see in something like Excel, but it's much more precise. So if we access a particular column or we input a particular set of information, we can see that even shifting a column left or right, by 1 unit could possibly cause a spillover of information that could expose a lot of protected information we wouldn't want to leave out there. The forgotten password example runs like this. An attacker enters a fictitious email address including a single quotation mark as part of the data. Now, SQL has some minor issues with quotation marks. Now, there are some sanitization things that are done here, but not a lot. The response indicates if the input is being validated, whether or not it kicks back a particular item. So we can figure out the different names of the field in the database, the name of the table, specific users, erase the table, or we can set it to transition information to a remote site or email. So the statement is then processed by the database once the manipulated injection line has been processed. So the example statement would be select field list from table where field equals whatever it is, or A is equal to A. So at this point we're saying we're going to do a character test to say if A is equal to A, then that's going to be true. If we have an or, then if we have any portion of an or statement referring as true, the whole thing becomes true. So the statement automatically becomes processed. So that would then display all email addresses. In this particular instance, again, if we have the correct information here to where we can see, if they don't have something to try and sanitize those inputs. Hijacking. Clickjacking we talked about a little bit ago. We also have session hijacking, URL hijacking, and domain hijacking. Hijacking is just where several different types of attacks follow the process of commandeering a piece of technology and then using it for an attack. You could have a hyperlink that's a single pixel wide, or you could have something that covers the entire screen of a page. Session hijacking is where an attacker attempts to impersonate a user by stealing or guessing the session token. Guessing is highly unlikely. This is a random string that's assigned to an interaction between a user and a web application. You can attempt to obtain this as an attacker by using cross-site scripting or using other attacks to steal the cookie from the victim's computer. If you have a Trojan or something that's in the browser, this can be an easy in. Eavesdropping on this transmission can also work, and again, it's not probable, but it's possible. Guessing the session token. URL hijacking or typo squatting. This is where users are directed to a fake lookalike site filled with ads for which the attacker can receive money, or it can sometimes be host to potential malicious software. Not great. Attackers will purchase the domain names of sites that are spelled similarly, common transpositions, things like that. Threat actors also register domain names that are 1 bit different. So goo.gl becomes foo.gl, and hopefully somebody just mistypes it. That's called bit squatting. And there are a number of companies that actually expend a fair amount of money every year just making sure that they have the most common variations locked down and being able to automatically redirect to the correct site. Domain hijacking is where a domain pointer that links a domain name to a web server is changed by the threat actor. When a domain is hijacked, a threat actor gains access to the domain's control panel and redirects registered domains to a different physical web server. So this would be hacking into like somebody's GoDaddy account or something similar to try and redirect information to a different physical site. Clickjacking, as I said, tries to take over your mouse click. You're tricked into clicking on something that is something other than what it should be. There are also 0-pixel iframes, inline frames. These are HTML elements that can be embedded inside of a main document, and they're virtually invisible, highly, highly dangerous for the untrained eye or an unprotected system. Overflow attacks, buffer or integer, of course. These are going to rely on trying to trip the sensor beyond some predefined maximum value. So overflowing areas of memory are going to try and push between something that would be safe to return versus something that should not be returned. So we see that the here they talk about the buffer, base pointer, and return function of the memory stack being potentially compromised because of these parameter changes, these out-of-bound array changes or memory jumps. In a buffer overflow attack, this is where a process attempts to store data in RAM beyond the boundaries of a fixed length storage buffer. The extra data flows into adjacent locations, and then the overflowed buffer can now have a new address, which would normally contain the return address of the processor, to move to the malware code. This takes advantage of the fail-safe nature of the overflow to try and run something that otherwise would be rejected by the processor or by the operating system. Integer overflow is a little bit different. This one's going to happen when the arithmetic operation exceeds the maximum size of the number type used to store it. So for an integer, if it's a 64-bit signed integer, there's going to be a maximum value there. The overflow is going to try and trigger that over the top value. And what this normally does is causing it to do what's called a wraparound. And this is where we're going to go from a very large positive value to a negative value instead. And depending on how the server is configured, it may respond differently to a negative value versus a very large positive one. So let's say, for example, we have a program that calculates the total cost of items purchased. Items, the number of units sold times the cost per unit. If we have an integer overflow introduced, it could result in negative values and thus a negative total cost. So if we had 100 units sold at, $25, then normally that would calculate just fine. But if we had somebody introduce a very large number that tripped over whatever that particular integer blank was, it would then kick it over to where units sold times, negative $25 or negative $150, and starts messing with the not times tables, I sound so immature when I say that, the multiplication tables that would result in the subtotals being different. If we have a negative total cost, that can actually hide inflation or over purchasing of other units. Advertising attacks, malvertising, and ad fraud. I always thought malvertising was such an awkward one to say. Malvertising is where threat actors use third-party advertising networks to distribute malware to those who may visit a well-known site. Malvertising is kind of the ad version of a watering hole or poisoned well attack. This is where an ad contains malware that redirects visitors who receive it to the attacker's webpage that then downloads drive-bys, trojans, ransomware, adware, scareware. Preventing malvertising is pretty difficult because website operators are usually unaware of the types of ads being displayed. Users will have a false sense of security going to a mainstream or well-known site, assuming that it would be better protected. And turning off ads that support plugins like Adobe Flash often disrupt the user's web experience. Now, I will point out this was written in 2018. Here we are in 2021. This is kind of dated because in December of 2020, Adobe finally discontinued support for Flash, using the update system to force uninstallation of the program itself because of all the security vulnerabilities. Now, there are versions of this that take advantage of HTML5, which was considered the proper replacement for Flash in terms of maintaining a greater level of stability. Ad fraud is where threat actors will manipulate pre-roll ads to earn ad revenue that's bounced back to them. There's a robo browser called Methbot, which spoofs all the necessary interactions to initiate, carry out, and complete ad auctions, so that way they can go ahead and purchase ad space that can generate revenue and possibly have malicious items attached, but still manage to not pay for that in certain ways. So again, there's the falsification that goes on here. Ad fraud is a really weird one. It's one I haven't had a lot of experience with, but it is apparently on the rise. Browser vulnerabilities, extensions, plugins, and add-ons. We talked about this a little bit ago with XSS. Scripting code is going to be allowing a browser to add dynamic content to its list of features. A web server will download a script or series of instructions in the form of computer code that allows the browser to perform actions outside of the norm. JavaScript is fairly popular for this. JavaScript will be attached in the form of a script, sometimes called an applet, that will be embedded inside the HTML document. Now, there are different defense mechanisms that are intended to prevent JavaScript from causing serious harm. For instance, JavaScript cannot access any local files through the browser. Java can, but not JavaScript. There are some concerns, however, because while JavaScript is running, any information that's going through the browser or being typed in a way that could be captured by the browser could be remotely transmitted to an attacker. So that means that things could be surveilled or sniffed much more easily. Extensions are kind of like the scripting code I was talking about, but they're usually installed as a component add-on to the web browser itself. Sometimes for a particular page, sometimes for a group of pages, sometimes to bind it to a particular program, to give extensions for things like Microsoft Office. A lot of extensions are written in JavaScript, except with Microsoft they use ActiveX, that's their own proprietary, so that these dynamic actions, these responses, or extensive calculations can be performed. Extensions are browser dependent, so that means that an extension that works in Google Chrome will not function in Edge, which will not function in Firefox, which will not function in Opera, etc., etc., etc. Now, it's pretty easy to port these extensions provided you understand how the API of the browser works. So that means that just because you didn't immediately see this particular extension doesn't mean it doesn't exist, which means it's pretty easy to corrupt them once they're there. These extensions being part of the executable code of the browser itself means that it's a little bit harder to detect potential malice in their execution. A plugin is going to add new functionality to a browser so that we can do extra activities, just like I said with JavaScript earlier. But these plugins tend to extend things that are much more powerful than just a standard scripting language like JavaScript or Python. This is going to be for something like Java, Flash, no longer Flash, obviously, Apple QuickTime. You know, now they have the Apple Music player that's built into websites like Genius and things like that. Adobe Acrobat to be able to deal with PDFs, things like DocuSign. Java can be used to create a separate program as opposed to a standalone executable called a Java applet. We talked about that a little bit ago with JavaScript. So the applet is going to contain statements that are from a fully fledged programming language, Java, and then be able to be executed as part of a web browser. So it's almost like the web browser is running a program within a program. And again, a fully functional program, almost like an exe. So that means there's a lot of potential for malicious code to be brought into play. Add-ons also give us a great deal of functionality. So they can create toolbars, change menus. They're aware of things that are open in the same browser, as well as processing the content of loaded pages. Now, due to the risks associated, we always want to be aware of how to block or minimize these particular impacts. Like I said, HTML5 is kind of the standardization so that Flash is no longer needed, so that we can prevent the security loopholes that are available. And thankfully, Adobe has already taken it off the table, but I'm sure it's not too long before something will be found that makes Flash more common for legacy sites. You know, I know the Supernova player already exists on gaming sites like Armor Games or Congregate. So we can see here just a little table that talks about the comparisons between extensions, plugins, and add-ons, what they are, where they exist, how the support works, and examples of things they do. One of the things I want to call attention to is the location. So extensions and add-ons are part of the browser itself. Plugins are part of the page, but provide some kind of link to an external program. So it just depends on what it's doing, whether or not we would be more concerned about a certain level of potential danger. So we always want to be aware that this is something that is pretty easy to have come about. You know, you can accidentally download an extension if you click the wrong window. More often than not, extensions have to be installed in the browser menu. There's usually a place where you go to download them. But you always want to be aware if it's trying to activate something that is not part of the standard browser, or if it's adding some kind of functionality that you know what it is. We talked about a little bit ago that mainstream sites are not safe the way people think they were. So you always want to treat any site that you go to as if it might be slightly suspicious. That is the chapter. So we managed to get that done in about half an hour. So if anybody has any questions or concerns, as always, you can certainly contact me through my Google Voice number, through my email, directly through Blackboard or Google Hangouts, or you can comment here on the old YouTube page. So if you have any comments on how I could do things better, anything that I didn't explain quite as clearly, or if you have a particular topic you would like to see, let me know. Other than that, I appreciate your time and attention as always, and I will see you next class.